Hello, grade 7. This is Mrs. Lopez. Today we are learning lesson 12, properties of inequalities in our module 3. Um, we've been doing equations all these times, and equation is something that has an equal sign. So it comes from the word equal, equations. Now we have inequalities. Inequalities is something that do not equal to each other. And inequalities, we have different signs instead of the equal sign. We have greater than sign, okay, greater. We have less than sign. We have greater than or equal to sign. Greater than or equal to. And then we have less than or equals to. Less than or equals to. Okay, these signs are very important to remember because that's what inequalities are all about. They have these 4 signs, okay? Um, so please, if you don't know what these signs mean, make sure to memorize that. Let's look at these inequalities. Here we have example 1. We have 2 integers. Integer 1 is -3. Integer 2 is 5. We know that -3 is less than 5, so here we have that inequality sign. So our inequality is -3 is less than 5. Now we will add an operation to it. Add 2 to both sides of this inequality. So here we will have -3 plus 2 is less than, still sign is the same, right? 5 plus 2. So now -3 plus 2 is -1, and 5 plus 2 is 7. -1 is less than -7. That is true. Notice that all these 3 signs stay the same. The sign is preserved. Preserved is like a preserve, like something stays the same. It's constant. It doesn't change. Okay? Okay, so let's work on this one inequality together, and then you will finish the rest of it by pausing this video and doing it on your own. Okay, so we have 4 is greater than -2. That is true. 4 is greater than -2. Now we are adding -3 to both parts of our inequality. So I'm going to rewrite that first. 4 is greater than -2. Now 4 is greater than -2, but I'm going to add -3 to both sides. -3 plus 4 and -2 plus -3. Okay, so now I have -3 plus 4, which is 1, and I have greater than sign. -2 plus -3 is -5. Is that true? 1 is greater than -5? Yes, it is. So the sign is preserved. Okay, so now you can go ahead and finish that on your own. Here we have 2 examples for you. And then once you're done, unpause the video and let's look at it together. Okay, so let's take a look at these 3. I have -1 is less than 1, and after I subtracted 2 from both sides by changing it to add the opposite, I got -3 is less than -1. Since this is still a true statement, my sign is preserved. Now I have 2 is greater than or equals to -3, and I have to subtract -1 from both sides. When I subtract the -1, I add the positive 1 instead, and I have 3 is greater than or equals to -2. It is still a true statement. The sign is preserved. -5 is less than -1. I need to add 1 to both sides. -5 plus 1 is -4. -1 plus 1 is 0. -4 is still less than 0. the sign is preserved. So what did we notice here? So when you did this, I hope you noticed that in some cases we were adding positive numbers, we were adding negative numbers, we were subtracting positive numbers, and we were subtracting negative numbers. So does that mean that when I add numbers, positive or negative, or subtract positive or negative, my sign stays the same? That's what it is. So when I add or subtract positive or negative integer irrational numbers, the sign of the inequality is preserved. So let's write that down in our conclusion here. When we add or subtract positive or negative rational numbers, the inequality sign is preserved. Okay, inequality sign doesn't change to anything. Okay, let's move on and see some more examples here. Same exact thing, now it's a multiplication. So let's do this one together. Negative 3 is less than 5. So we multiply both numbers by negative 1. Negative 3 times negative 1 makes a positive 3. And 5 times negative 1 is negative 5. Is 3 less than negative 5? No, 3 is greater than negative 5. That's why we need to reverse the sign. So reversed sign, we should have 3 is greater than negative 5, right? So that's what it should be. The sign is reversed. Let's look at 4 is greater than negative 2. 4 is greater than negative 2. Now we need to multiply again by negative 1. All of these actually are multiplying by negative 1. So 4 times negative 1 is greater than negative 2 times negative 1. 4 times negative 1 is negative 4. And we have negative 2 times negative 1 is positive 2. So I see negative 4 is greater than 2. Is that true? No, it's not. We have to have negative 4 less than 2. Okay, so the sign will have to be reversed. Reversed. Okay, so go ahead, pause the video, and see how it's true for all of these inequalities. All right, here in the third row, we have negative 1 is less than or equals to negative 1. We are multiplying both sides by negative 1. And what we get is not a false inequality that is 1 less than or equals to negative 1. It's not true. So that's why I crossed it. And we should have 1 is greater than or equals to negative 1. The sign gets reversed. For the next one, we got negative 2 is greater than or equals to 3 after the multiplication. That is not a true statement. That's why I crossed it off and I changed it to negative 2 is less than or equals to 3. So the sign has to be reversed to make it true. Negative 5 is less than negative 1. After multiplication by negative 1, the sign has to be reversed again. 5 is greater than 1. So after we look at all of these examples, we can make a conclusion so that when we multiply a number by an inequality by negative 1, the inequality sign gets reversed, right? So let's write that down. When we multiply both parts of inequality by negative 1, on both sides. Inequality by -1, the inequality sign is reversed. Okay, so far we have when we add or subtract any number, the sign is preserved. But when we multiply both sides of inequality by -1, the sign gets reversed. So let's take a look at some more examples. Here's some other multiplication that we will look at, and some of them are fractions because there is nothing wrong with multiplying by a fraction. Go ahead and do that by yourself, and then we will check the answers. So please pause the video now and do it by yourself. All right, so what I have here, after I multiplied both parts by 2, I got 8 is greater than negative. True, the sign is preserved. It is a true statement. When I divided by 2, which is the same thing as multiply by the reciprocal, 1/2. So I was multiplying -1 by 2, and I got -1/2. By 1/2, sorry, and then I got +1/2. Again, -1/2 is less than or equals to 1/2, so the sign is preserved. Here I have 2 is greater than or equals to -3, and I need to divide that number by 1/2. So I have the division sign by divide by 1/2. When we divide by a fraction, we need to multiply by its reciprocal. So times 2/1 for both numbers, times 2/1. And the same goes for the right side as well. So I have here 2 times 2 is 4, and -3 times 2 is -6. All the denominators go away. 4 is greater than or equal to -6, so the sign is preserved. It is true. -5 is less than -1. We multiply both parts of my equation by 3 and get -15 is less than or equals to -3. This is true statement, so the sign is preserved. Okay, so take a look what we did to these numbers. We all multiplied them by either fraction or a whole number, but there is no negative numbers here. So we can say after we multiply by a positive number, this inequality sign is preserved. After we multiply by a positive rational number, the sign is preserved. When we multiply both parts of the inequality by a positive rational number, by a positive rational number, by a positive rational number, the inequality sign is preserved. Okay, let's look at the next one. Now we have multiply and divide, and all of these numbers are negative. Some are fractions, some are negative integers. So let's take a look at how that changes our situations, our inequality signs. So go ahead and pause the video, do it by yourself, and then we'll compare. All right, so as we can see, in all the cases, the sign has to be reversed. And those are the cases when we are multiplying or dividing by a negative number. It can be a fraction or it can be a whole number, it can be a decimal. So the sign reversed when that multiplication is by a negative rational number. Okay, so when we multiply both parts of both sides of the equation, of the inequality, sorry, by a negative rational number, the inequality sign is reversed. Okay, and we have one more here, last one. We will need to complete the following chart using the given inequality. Determine an operation in which the inequality symbol is preserved and an operation in which the inequality symbol is reversed. So let's take a look up here again at our three previous tables. When we looked at it first time, 4 tables, we added or subtracting either positive or negative integer, and the sign is preserved. Here we were multiplying by a negative 1. In all cases, the sign was reversed. Here we multiplied or divided by a positive number, and in all cases, the sign is preserved. And in last case, we multiplied or divided by a negative number, and in all cases, the sign is reversed. So when do we reverse the sign and when do we preserve the sign? When we add or subtract positive or negative number, or when we multiply or divide only by a positive number, the sign is preserved. It reverses when we multiply or divide by a negative number only. Okay, so let's take a look back here and see what we can do to preserve or reverse the sign. So I have 2 is less than 5, and to preserve the sign, I can add or subtract or multiply by add or subtract by any number or multiply by a positive number. So I'm going to go ahead and add negative 4 to both sides. So 2 plus negative 4 is less than 5 plus negative 4 as well. So 2 plus negative 4 is going to be negative 2, and that is less than 5 plus negative 4 is 1. That is true, so I did it correctly. I would reverse the sign when I would say multiply by negative 4. Instead of adding negative 4, I will multiply by negative 4 both numbers. So 2 is less than 5. And now I'm going to multiply 2 by negative 4 and 5 by negative 4. 2 times negative 4 is negative 8. And 5 times negative 4 is negative 20. Negative 8 is less than negative 20. That is not true, so I will have to change the sign. Reverse it. Negative 8 is greater than negative 20. Okay? Negative 4 is greater than negative 6. Negative 4 is greater than negative 6. So I was adding a negative number. Let's now subtract something. Negative 4. Let's subtract negative 4. I like that negative 4 example. Subtract, well, let's subtract 4 actually. Let's subtract 4 is greater than negative 6, and I will subtract 4. In this case, I put the parentheses in this case I didn't, just so you know that I can do anything really, because I will have to change my subtraction into plus the opposite. Okay, so I will have to negative 4 plus negative 4, and that will be negative 8 is greater than negative 6 plus negative 4 is negative 10. That inequality is correct. Now I'm going to, let's again multiply by a negative number. So negative 4 is greater than negative 6. Let's multiply by negative, well, let's stick with that 4. Negative 4 times, times negative 4 greater than negative 6 times negative 4. So here I will have 16 is greater than 24. That is not true, so I'll have to reverse the sign. 16 is less than 24. Okay? Negative 1 is less than or equals to 2. Let's multiply by a positive. Negative 1, let's take 5. Negative 1 times 5, less than or equals to 2 times 5. Negative 1 times 5 is negative 5, is less than or equals to 2 times 5 is 10. That is a true statement. Negative 5 is less than 10. In this inequality, we also have equals to. That's okay. It's just the sign that we have here, less than or equals to 10. Okay, and in this case, when negative 1 is less than or equals to 2, let's divide now instead of multiplying. Negative 1, let's divide it by 5 again, negative 5. Let's divide by negative 5. Okay, so less than or equals to 2, and we'll divide by negative 5. Dividing by negative 5 is the same as multiplying by its reciprocal, right? So the same thing as multiplying both numbers by negative 1/5, right? So here I will have positive 1/5 less than or equals to negative 2/5. That is not true, so I have to change that inequality. 1/5 is greater than negative 2/5. Okay, and in the last one, I have negative 2 plus negative 3 is less than negative 3 minus 1. Let's combine like terms first. Negative 2 plus negative 3 is negative 5, is less than negative 3 minus 1, which is the same as negative 3 plus negative 1, is negative 4. Okay, so now we have negative 5 is less than negative 4. So we did addition, subtraction, multiplication. Let's do division by the positive number. Negative 5 is less than negative 4, and let's divide it by 1/2. 1/2. Since I'm dividing by 1/2, I will have to multiply by its reciprocal, which is 2, right? Both multiplied by 2. So I'll do times 2 here and times 2 here. Times 2 times 2. All right, so now I have negative 5 times 2 is negative 10, less than negative 4 times 2 is negative 8. Negative 10 is less than negative 8. That is a true statement. Instead of rewriting this I will just rewrite that because I already added like terms. It's going to be the same thing. Negative 5 is less than negative 4. Okay, let's again divide by negative 1/2 this time and see what happens. Negative 5, we are dividing by negative 1/2. And that is less than negative 4 divided by negative 1/2, which is the same as multiplying by negative 2, right? Reciprocal of negative 1/2 is negative 2. So negative 2 on all sides here. Negative 5 times negative 2 is going to be positive 10. And negative 4 times negative 2 is going to be positive 8. 10 is not less than 8 anymore. 10 has to be greater than 8. So that's how our inequality sign changes. Okay? Now you can come up with different numbers and try it by yourself and see what happens. But that is our lesson summary. When both sides of an inequality are added or subtracted by a number, the inequality symbol stays the same. The inequality is said to be preserved. When both sides of an inequality are multiplied or divided by a positive number, the inequality symbol stays the same. The inequality is said to be preserved as well. When both sides of an inequality are multiplied or divided by a negative number, the inequality switches from less than to greater than or from greater than to less than. The inequality symbol is reversed. All right, so that is all for this lesson. If you have any questions, please message me. Otherwise, do your homework and I will see you or talk to you in class.